We started off with our cosine difference formula, and we went from there. We created our sine and tangent difference formulas. We created our sum formulas. Now we're going to look at half angle formulas and power reducing formulas. And these will come from the double angle formulas. Again, those came from our sum formulas. And we're going to specifically focus on the cosine 2 thetas formulas, the 1 minus cosine 2 theta equals 1 minus 2 sine squared theta, and cosine 2 theta equals 2 cosine squared theta minus 1. So focusing on the sine squared version. Cosine 2u equals 1 minus 2 sine squared u. If I add 2 sine squared u to both sides, and I subtract cosine 2u from both sides, I end up with 2 sine squared u equals 1 minus cosine 2u. Divide both sides by 2 to get sine squared u by itself, and I have sine squared u equals 1 minus cosine 2u over 2. This is actually our power reducing formula for sine squared. Anytime we have a sine squared of something and we need to turn it into a lower power, we can use this formula to turn a sine squared into a cosine. Again, part of the reason why we're doing all of these formulas is because there will be times in calculus when we need to rethink the meaning of something, or we see the meaning but we need to rewrite it so that it looks differently, so that we can use one of our formulas or our rules to do the integration. Moving on, now we have the sine squared u equals 1 minus cosine 2u over 2. Square root property says that means that the sine u is positive or negative square root of 1 minus cosine 2u all over 2. At this time, we're going to rethink the way we look at this again. If we think of 2u as being x, then that means u would be half of x. And that's how we get it to the final form of our half angle formula, which is sine of x over 2 is equal to plus or minus the square root of 1 minus cosine x all over 2. And I've got x. It works for theta. It works for whatever our variable is. The plus or minus may be a little troubling because we know that sine of an angle isn't going to be plus and minus. What we have to do is figure out what quadrant this half angle is going to be in order to determine whether it's going to be a positive or a negative value. Let's look at that a little closer. So how do we know what quadrant we're in? We'll start off by looking at what quadrant the original angle is in. For this example, I'm going to say it's in quadrant 2, which means we're between pi over 2 and pi. Or if you prefer in degrees, it means we're between 90 degrees and 180 degrees. What I can do with a compound inequality like this is divide each term by 2, and when I do that, it gives me the compound inequality that x over 2 is between pi over 4 and pi over 2. It's a quick conversion that you can use, and that will help you figure out what quadrant your new angle is in. Looking at this a little further, if we're in the first quadrant, meaning we're between 0 and 90 degrees, or 0 and pi over 2, then our half angle is also going to be in that first quadrant. If we're between pi over 2 and pi, then our half angle will be in the first quadrant. If we're between pi and 3 pi over 2, then our half angle will be in the second quadrant. And if we're between 3 pi over 2 and 2 pi, then our half angle will be in the second quadrant. It depends on your original angle, and these original angles, remember, I could be looking at, say, 9 pi over 4. 9 pi over 4 is in the first quadrant, but I can't use this up here because 9 pi over 4, when you cut that in half, you get 9 pi over 8, and that's the third quadrant. So be careful with this. Just what I do is plug it up here and figure out what quadrant we're in, and that'll determine whether the sine and the cosine are positive or negative. Continuing on, if we have cosine of 2u equals 2 cosine squared u minus 1, again, this time I'm just going to add 1 to both sides to get the 2 cosine squared u alone, and I'm flipping my sides around. So adding 1 to both sides, I get 2 cosine squared u equals 1 plus cosine of 2u. Divide by 2, and once again I get my power reducing formula for cosine. So anytime I've got a cosine to squared, cosine to the fourth, if I need to reduce the power, I can use this formula to get away from having the cosine squared. Using the square root property again, I get cosine of u equals plus or minus the square root of the quantity 1 plus cosine 2u over 2. And now by rethinking the variable, I can change it to cosine of half of an angle is plus or minus the square root of 1 plus cosine of the original angle over 2. Tangent. Tangent gets a little trickier. Tangent's kind of like the cosine, where we've got 3 different possible ways of looking at it, the double angle cosine. Well, looking at tangent, I'm just going to start off by substituting in the original formulas for the half angle sine and half angle cosine. If we invert and multiply this, we'll get the plus or minus the square root of 1 minus cosine x over 2 and times the square root of 2 over 1 plus cosine x. The 2's will divide out, and we end up with plus or minus the square root of 1 minus cosine x over 1 plus cosine x. We can split that into 2 radicals, which I do here, and you get square root of 1 minus cosine x over the square root of 1 plus cosine x. At this point, I'm going to rationalize my denominator, and I'll do that by multiplying it by the radical in the denominator. And when I do that, I get a 1 plus cosine x in the denominator, and I get 1 minus cosine squared x, because we have the difference of 2 squares, multiplying a sum times the difference. And with the Pythagorean identity, that tells me that we have the square root of sine squared x. And the square root of sine squared x is sine x. So this gives me the tangent half angle formula. Tangent of x over 2 is equal to sine x over 1 plus cosine x. However, if when we rationalized our denominator, we could have gone a different direction. What if we had instead multiplied by the numerator? We would have 1 minus cosine square root of 1 minus cosine x times the square root of 1 minus cosine x. That product gives us 1 minus cosine x. And then the denominator would have the square root of 1 minus cosine squared x. Well, now the denominator can be simplified to give us sine x, and the numerator is 1 minus cosine x. So that gives us 2 possibilities, actually 3, for tangent of x over 2. Our half angle formulas are sine x over 2 is plus or minus the square root of 1 minus cosine x over 2. Again, we have to pay very close attention to what quadrant this half angle is in. Cosine of x over 2 equals plus or minus the square root of 1 plus cosine x over 2. Again, we have to pay attention to what quadrant we're in. Tangent of x over 2 is equal to plus or minus the square root of 1 minus cosine x over the square root of 1 plus cosine x. Again, paying attention to what quadrant the angle is in. Now, the way we did these formulas, it turns out the plus or minus does not come into play anymore. Tangent of x over 2 is going to be sine of x over 1 plus cosine x, or 1 minus cosine x over sine x. And again, these will take care of the plus or minus part for us, since we don't have the radicals. I'll continue with some examples in the next video.